All right. I apologize for missing Monday. Hopefully, sounds like things were a little confusing on Monday. So if there is any questions that anybody has that you want me to go over before we go on to additional examples today. So any questions from last Monday's problems that you guys went through? So this was one of them. Yes. So colors. This one, so down here. All right, so in this red one, combine the bottom, so it ends up the two S's cancel. And then I think what I did here. 11S, success. Okay. A little room to write. Cool. Sorry, just trying to remember what I did. S over 2, and then I plugged in V1. Okay, I see what I did. Okay, so then so making a common denominator here is 12. So this is going to give 2 over 12 6S plus 3 over 12. This is going to get messy. Let me copy this. Sure, copy that right. Okay, so minus 6 or minus S over 2. And then this was 11 plus V2S squared to get an S on the bottom. And then this was 2S, which canceled those, S squared plus 2, S plus 2. Okay. And then again, you need to bring out, this is S, not. I'm just kind of doing this. Are you guys following as I'm doing all this? Stop me if I do a step and you're like, what did you just do? Three. Maybe squared. Okay. Thirty-three times two is 66, right? 66, 22, 88. 88 squared. There's two. 17 is 2. Okay.
Hey, quick question.
Yeah.
How did we get from the 22 s squared to the 88 s squared?
So I combined the 22 and the 66 to give me 88 s squared.
That makes total sense. Thank you.
No worries. And then 22s and then 44. 22 into 88. 4. Is that for us? That right? I have an error somewhere. Let's see, what did I end up with? Sure we get to this one. Where's squared plus s plus 2? Okay, I'm getting there. So bring out 11. And then factor this. This is going to be s is equal to minus 17 over 11. So hopefully my math was right, and this ends up being the 0.77 plus or minus 0.56J. So be minus plus 7. Fun algebra. Calculator, make sure that is. Got a different first number. I got 1.54 divided by 2. I think I forgot to divide it by 2. Yeah, 0.77. Okay, yeah. So that does work out to be correct. Okay, questions? No. It's good exercise to go through these algebraic challenges and then use an online calculator to help you get there.
Oh, when you had it like up a little bit before you brought the 11 out in front, it already had the S at the bottom, so you could you have just done the roots from there? Instead of bringing the 11 out and then going into the top and stuff. Or just be massive and roots.
I usually don't find roots that way, so That looks harder to me to figure that one out. So that's why I multiplied it all out, because I'm like, well, if I multiply it, then I combine them, and then I'll
Quick
solve.
question online.
Yeah.
Looking at the very bottom answer, is there an exponent that says to the 2s, or is that copied from like above? Does that make sense? Like that 2s, is that to the power of 2s, or was that from a snapshot that just happened to make it down there?
That was from the snapshot.
Okay, great.
So that should be exactly the same. Did that answer your question?
Me, yes.
Okay. All right. And there was another yes.
So if you scroll up, before you multiply the two fractions, like both sides have the s squared plus s plus 2. Can you cancel them again on the other numerator and denominator?
Wait, where?
So, like the third line up, when you're multiplying the two, yeah, that one.
This one?
There's like you still kept one s squared plus s plus 2. Could you cancel that out also from the other denominator?
So this is more of an actual quantity here. So it's not a separated, it's only separated when it's in the numerator, not when it's in that denominator. So it has to be the whole quantity. And so you can't, so it's that quantity multiplied by this one, because of that multiplication. And that's why you can cancel that out. So only be one. All right, other questions?
So that -6x cubed was not there, you wouldn't do anything? Yeah, so the thing.
Yeah, so if it was this, it would still only cancel one. Because it would be that multiplied by itself again. So it only cancel one portion of one of those. Right, because it's like that quantity squared in the bottom now and once on the top. So it would only remove one of them on the bottom. Let's do that. There we go. All right, any other questions on this? A lot of algebra. Fun. Okay. Any other questions about the other problems? Or anything else about these problems that you guys had? Were you able to get through both problems on Monday? No?
No,
Okay.
the videos didn't work, so we kind of just talked about things rather than going through them.
Okay. Videos didn't,
Sound of them.
oh, the sound wasn't working.
You only was able to get sound over sometimes.
Okay, so I'll leave it because it's already a video out there. I'll leave it as like, you guys can use this as an extra practice problem. We'll move on so we can work through solving others. And then if you want to use that solution is there. And so you guys can go back and use that as another practice problem. Does that sound like a good plan? Okay, so that will give you another video solution if you want to go through. Okay, so we are on 10 now. Oops, that's old. 10 notes. Okay. So let's work on this problem, which will be new. So same technique. What's the steps to solve this? So what do you need to do first?
Initial values.
Okay. So find initial values. How do you find those initial values?
I believe we will short the power source, open the capacitor, and short the inductor.
So to find the initial, you're going to change first. You need to find out what the value of VS, that source is before. So it doesn't just short it. You need to see what is the value before time 0. In this case, what will that be? It will be 0. Why? because
Because
of the
there's no
step.
shift in the UT.
Yep, so that step function means that anything before times 0 is 0, anything after will be the value of 2. Okay, so that gives you that initial value will be 0, and then you do what you said, which is open up the capacitor and short the inductor, and then find your initial values for that VC of 0 and IL of 0. What will that be if VS is 0? So both of them will be 0. Yes.
So what is an example of a step function that would have initial values? So like that 2 U of T, right, that says that we have no initial values. Is there something that could be added on to that, like that weird notation?
So if I had, so say a shift. So if I had something like this, where I actually have a value before it.
So what would that look like mathematically?
So you would assume that this value here has been sitting there for a really long time. Say it was 2 volts. Then this would be 2 volts and these would be open. Let me get a bigger one. And this would be shorted. Oh, that is very big. And so in this case, I'll VC2. How do you find that value?
Down, well, these two can be 2 volts. For the V charger.
This is 1 ohm, this is 3 ohms.
Voltage divider.
Okay, you could do voltage divider, or you love mine, node voltage. So treat that as a node there. So just do VC2 minus 2 over 1. And then just solve that for VC2. And that will give you the same equation. And then IL will be what?
R1 plus R2. And then you do 2 volts by that. Yeah.
So you could do the voltage divided by 4 or VC2 over 3. Which is going to be the same. So either one of those.
Question for you.
Yeah.
If we're doing VC2 at 0 minus, why is it 2 volts and not 0 volts? Is that because we transformed to the S domain or something?
That was just as an example for a question that was in class.
Gotcha, thank you.
Is if, so I'm going to erase this one. I'll put if signal below. So if it was this signal where you have 2 volts as that source.
So yeah, how would you write that out? 2 U of T.
Oh,
minus
the equation for this, you mean?
1.
Okay, so I would have to know these values. So let me pick some, let's see. T equals 2, and we'll do T equals minus 2.
Question for you.
Yeah.
And so in order to have an initial voltage that's not 0, there would be a shift, correct? Would it be like a U of T minus 1 or something like that?
Sorry, say that again.
I'm just wondering what the well, actually I'll watch the example, thank you.
Okay. So to write this, anybody have any ideas on how you would write this?
Plus 2.
And what does that look like if you have a T plus 2?
Mhm.
So it's going to come up at, so it's going to look like that one. So we have that one at a value of 2. And then we need to subtract off this portion, right? So we need something that comes up and then is subtracted off. And so what will this one be? And so this would be T or find a different color. 2u of t plus 2 minus 2u of t minus 2. Okay. That would be how you'd write that one. All right, other questions? Where did my page go? I'll paste. There we go. Okay, so going back to the original problem. All right, so we have initial values. Then what do you do?
KVL, KCL, or node voltage to set the equations.
Okay, so we need to get equations, but we need to do one more step before we move to equations.
Laplace transforms.
Assuming that was what you were going to say too. Okay, so Laplace transforms. Okay, so Vs of t is going to look like what? Okay, so the Laplace of Vs is just going to be 2 over S. And then we have 0 for the initial voltages and current. So we can just write the impedance as 1 over CS and 1 or LS for the inductor. Once we've transformed them into the S domain, you treat them just like any other resistance. All right, so go ahead and now work in small groups. To solve this, you're trying to find V of t, which is across the capacitor. So that's what you're trying to solve for here. I'd also like to introduce you, Elmer. Do you want to stand? Thanks. So a TA in training is here also. So he's going to kind of help go around and you can ask him any questions too.
Yeah, I can't guarantee I know how to do it well. There's no voltage source right there. Values, right? Voltage across this matter. So we use lost from the past. Voltage source. But if they're yeah. Thank you. I'm not. Values for LDC. Those are becoming, those are very. Yeah. So I believe I would have. It's just before. Oh, yeah.
I could write those.
Is that the problem with someone?
Uh-huh. Yeah. Draw these in.
Okay. Which one is this?
That looks messy though. I'll redraw those.
Yes. No, that's sorry, yeah, I'm just saying. That would just be at silver.
I'm a little bit confused because there's not just this one on this sometimes and when it goes so this would be if you want to if you're going is that right? Oh, so it's like
Not that good, but that's happening. I go to my. And then we say, yeah, it's perfect. This is what you're. You already like this. And then it's wire. I couldn't write it. I wrote like less fast.
So what I combine there.
Yeah. Oh, yeah. Because it's like. So it's. Okay, can we do double portrait questions? It doesn't work. It's that. It's so rare. Yeah. That might provide a really good business. Yes, we have. Well, right, it's taking. I can't, I can help, right? Under. Oh. And then.
Oh, is this really just SC? That's. Oh, yeah. Did I want to divide this forever so I can next way to these two?
Yeah, right. Really good point. Yeah.
I'm recording this.
It looks like they're wrong. You just simplify it? Yeah. Okay, I did nothing on. Yeah. Maybe she could just have. You went ahead and did the whole thing, right? Yeah, this would be in the denominator, and then you flip, and then I would get that.
And that's how.
That's the same. Yeah.
You're only getting 3 decimals for that.
Yeah, you got
Yeah, that's what I'm saying. You should probably stop. What's faster? You want me to go, do you want me to see if there's a magic airplane? It doesn't matter. It's able to solve. What's the equation? Oh, no. Do we go actually quickly? Are we gonna see imaginary?
So. Yeah.
Oh,
So get very comfortable with. But anytime you have a fast, you're gonna need, anytime you have an industrial company. The more you have, the more time, like, it's gonna be. Necessary.
You guys didn't talk about exploring the magic. So you guys know we get the GA. You guys
know.
plug it in. Okay, all right. So we're like doubting our calculations. Oh, yeah. No, you see me? What's your estimate? This question might be more. Yeah, there's an that gets canceled on the time. No, in the radical. I'm just checking. I'm not calculating the entire. I was just thinking. So. We know. Yeah. Oh my God.
I know that.
Yeah. I'm saying relative to my homework, this is nice.
What the denominator would be X and the S, look at the.
Yeah, you look at it. It's a few good stuff. What's your rationale? Oh, you're literally doing.
What's nice is you don't have to apply on that most you can set else. You don't have to all the others. Put it all over. It makes it a lot easier to see.
Yeah.
Yeah.
Now we have. It's not.
Yeah.
I got two random questions out.
My character is not able to keep exactly do that. Huh? I'm doing it in my head. So it's- Oh, right. I still don't like it. I think being certain about deleting everything, because it's just forever. Negative sign. That's like key. Negative. Yes. So do I have to go over the? Give me a second. I'm gonna do this slowly.
Professor Rasmussen,
Yeah,
could you show me how you got the Vx over 2.71 over S, please?
so
Then you can just do partial. And it's easy.
I just think I transformed my capacitor wrong and would like to see an example.
one over, let's see, was point,
This one? For A.
so one
Oh,
over
okay.
369 is also 2.71 over S.
That makes sense. Thank you.
Okay, so as you know, I like node voltage. So node voltage equation, I drew all my arrows going out. Some of you, as I walked through, some of you were drawing your arrow going in and then the two going out. If you do that, that's fine. You just have to describe that current. Remember, you start on the positive side of it, which is away from the arrow, minus whatever it's going into on the arrow side. And so Vx minus 2 over S over 1. And then the current going down is going to be Vx over 2.71 over S, or Vx over 1 over 0.369 S. And then plus Vx over 3 plus LS. And so this was one thing I saw some people forgot, is that you treat that inductor or that capacitor just like any other resistance. So even though it has an S in there, you have to just add it to the 3. And then from here, I combined all of the Vx's. And then I took the 2 over S to the other side and then divided by the Vx. And then I need to get a common denominator for that one. So I use the 3 plus 0.2259 S. And I multiply that out so that it becomes the 3.2259 S divided by 3.2259 S becomes, this is your 1. And then this portion is the 0.39 or 369 S divided by that. And then, oh wait, that is not. Do it this way. There we go. So it's those two terms. So that's 0.369 S times 3. And then the other one is 0.2259 S times 0.369 times S. So that gives you the S squared, and then plus 1. And then from there, you bring up the bottom portion to the top. So you have 2 over S, and then S squared. So then I need to factor out. So my number, when I'm finding the roots, when you do partial fraction expansion, you always need to make sure that that S squared is a 1. So you have to bring out any other number from that. So if I bring out a 0.083, then I have to divide the other two by 0.083. So there's a division there and a division there. And then this is out front. And then you divide the top portion of that. So 2 divided by 0.083, or I guess it would be 6 divided by 0.083 becomes 72. And then the next term becomes 5.443. And then on the bottom, this becomes S squared plus 16S plus 48. And then factoring that, I get 4 and 12, or a -4 and a -12. So that gives me a factored form of S plus 4, S plus 12. Okay, questions? Okay, get good at some of your algebra manipulations, or get very familiar with a calculator that you like to use that will do the algebra for you. Either way, just make sure you know how to get to this point. And then from there, do partial fraction expansion. So I'm going to hide that for a minute. So go ahead and assume that you did get to this point. If you did not, make sure you go back through these notes and figure out how you didn't get there. Okay. Yes.
Sorry, so when you did the S, we have to fix the S to 48, you're just assuming they're close enough to say 48. So we can do that. Wait, so I am.
Yeah. So I did round to a nice number. Otherwise, let's see what is it? Let's see, 1.333. So it's 16.1.
Yeah, because.
So to me, that's close enough to 16.
Yeah. Let's just add, we're gonna just do that, it's
Mhm.
doing it all the best.
Yeah. Yeah, so if you're dealing with a decimal, it's going to make it a little bit harder. So his question is like, when can you round? Like I rounded to 16 and it's like 16.1 is the actual value. So when is it okay to round? When you're doing it by hand. So if you can round to a nice even number, I mean, if it was 16.5, I don't know if I would go to 17, but 16.1, 16.9, I would round to 17. What you're trying to do with hand calculations anyway is to get a ballpark figure and then take it to a simulator that's going to give you the very accurate numbers. And so as a designer, that's really always what you're going to do is like, okay, I want to do some hand calculations to get a ballpark figure. And then go from there to a simulator. And then you're going to actually build it and they're going to still be different. And then you're going to want to understand, well, do I want to increase that value or decrease that value to get to what I want it to be? And so as a designer, that's the thoughts that you're having in your mind of what changes do I want to make and do I want to increase or decrease it? So for example, see if I could figure out a question that I could ask for that. This isn't an easy one to look at and say that, but sometimes you can look at like a solution and be like, well, I want this to be, the 1.5, which is my A value. I want that to be 5 volts instead. So how could I go about getting that to be 5 volts? Obviously, one thing you would need to do would be the power, because you need something higher than 2 volts to get 5 volts in a circuit. So I could increase the power. But here, the 2/S is getting reduced across the VC or to be like 1.5 volts. So maybe I don't want to have so much dissipation. Maybe I want 1.9 volts. So what component value could I increase or decrease there? So then you have to go back to A and look at A and say which factors are in there. This is not an easy one to look at and just say that. But that would be kind of what you would do as a designer. Okay, so do the partial fraction expansion on this and figure out what A, B, and C are. So mhm. So this point, so I have 6 divided by 0.083. And that becomes 72, yeah.
Did you see? No. What are we missing? Why did we, oh, is there 6 still?
So do you get to the 0.083 as squared on the bottom?
So we get everything before, you changing, assuming 16. Before that whole thing. We didn't factor out the 0.8.
So you got this one right here.
Where?
Maybe do it. This quantity here.
Yeah.
He's saying yes. Okay. So from here, okay, so from here, in order to do partial fraction expansion, you need S squared to be 1 in front.
You need it to, or is that just a help?
You have to, in order to do the partial fraction expansion, it has to be of the form of S where it's 1 in front of it, plus some number. And so when you factor it, this is called the standard form. So you always have to bring out any number in front of it so that it's a S alone. Yeah. So that is definitely,
Yeah.
kind of have to understand that you got to do that for the standard form. So you always need to make sure that there's a 1 in front of that in order to then factor it into the partial fractions.
Okay, that's why I like it breaks, because I still have that coefficient.
Yeah. And then that 0.083, when you bring it out, you divide the 6 by that, and that becomes 72.
Yeah, 'cause we did it all, and we still have that thing. Makes the notes that A value is very high.
Hmm. Yeah.
Like, we sent it through the calculator, and it was able to calculate it. So now we know to pull out 11.8.
You need a 1.
So
You
we
need a
did
1
the
there.
project, S squared, 0.83, and all that. We sent it
Uh-huh.
here, and it gave us that. Now that you know, you have to do.
Were the roots 4 and 12?
Yeah, they were like approximately.
So I'm gonna have to get a good answer for you, but right now it's just because it's a standard form that you always end up getting it into always having a 1 in front. So when you're working with real circuits, I can't think of how to describe this, so I'll think of a way to describe it better, but that is, you always want to make sure there's a 1 in front of that. So all of those numbers give you, they mean another magnitude, and it means something for a circuit. And so you just need to get it in that form.
Yeah.
Okay. So Lawrence brought up a good comment. So make sure that you're getting it into this form, which we call the standard form. And this is because we're working with real circuits. Those numbers that are the coefficients out front of this form now, they mean something. And you're going to get into that in 2280. They actually tell you some information about the magnitude of what your circuit does. So if it's an amplifier, it actually tells you how much it will amplify it. And so we use this standard form, which is where there's always a 1 in front of the S squared or whatever S's there are. So the highest ordered S has to have a 1 in front of it. And that means if it is a number, you've got to take it out and divide it by the rest of the numbers out in the numerator. And then that number corresponds to, like what I said, it actually means something as a circuit. So that number out front now means it's a magnitude of the circuit. So if this was an amplifier, it actually tells you how much amplification it gives you. But that you have to have it be a 1 there. So in this case, we have to take out that 0.083 and factor it into the other numbers. So we end up with that 72 on top. Okay, so don't forget that step because that's a little intricacy that has to do with now we're working with real circuits and those numbers do mean something. So it's important to bring that number out to understand what the coefficient values are on the top. All right, anybody, you guys find A? Raise of hands. People found A? Okay. B? You guys find B too? Okay. Some still hands. C? Okay, so most people have found A, B, and C. All right, questions about A, B, and C? Okay, once you find A, B, and C, now you can easily look at the Laplace tables and say like, well, A over S is going to translate into or back into A times U of T. And so I get this first term. And then S plus 4 on the bottom translates into E to the minus 4t for the second term. And then the third term will just be the number E to the minus 12t. So that gives me my voltage equation. And note that Vx of t was your Vc of t. Which was what you're trying to solve. So I'll post these notes. You could do this another way where you combine all 3 of those resistances. Again, you can treat these just like resistors are values. So you could combine this as 3 plus LS in parallel with that capacitor. And if that's the case, you get like an R equivalent. And then you can just do either voltage division or node voltage from there, which is just going to be Vx minus 2 over S divided by 1. And then the R equivalent will just be Vx over R equivalent. And so that will then solve to give you this equation. And you can then go and manipulate that algebraically and get the same solution. So that's just another way of solving for this. Okay, questions?
Quickly show the DC.
Yeah, so I'll post these notes. And then I'll post also the notes from Monday where it's just written out if you want to just follow it easier instead of just from the video. And then tomorrow you have your discussion for this week, so make sure to submit that. And then you also have Friday homework will be due. And Saturday will be your quiz, but I encourage you to actually do your homework tomorrow and start quiz on Friday, just so you have the weekend. It will be one of these circuits, so you will be working on, the homework will be one of these, and then the quiz will be one of these circuits. So it would be to solve the full circuit. Yes. What do you mean, practice problems? Oh, yes, I haven't posted those yet, have I? Yes, I will create that unit 2 practice problems. So that will be the same. If you've missed homework and want to use that as a makeup homework, you can do that. And then you can also use it to help prepare for the exam. So it'll be solutions for those.